Hello, welcome everyone to the May Fundamentals. I'm Ron Ziss, and I'm going to be talking about galaxies tonight. I really upped my experience with galaxies by participating in the Astronomical League's Herschel 400 program. And it was about as much fun as I've had with my hobby. And I completed that program, ironically, by doing three things that were not recommended or required by the Astronomical League, but which definitely helped me. The Astronomical League said that you should use telescopes of about 10 inches of aperture or larger, but I used small telescopes, 6 inches in aperture or less, and the reasoning that much that is visible in a large telescope can also be seen in a smaller one, and my small refractors were a lot more portable to get to my Stark sets. The Astronomical League also required just that you check items off a list, but I chose to make drawings of each of the objects, which trained my eye not to overlook things. And lastly, the League encouraged go to and other electronics in order to locate the objects, but I chose to find them all the old-fashioned way by star hopping, so that I could learn the sky and the constellations. So though I did this all low-tech, I did wind up recording all of the Herschel 400 objects, and that included over 231 galaxies. And when I added galaxies I saw through the Messier program and others on my own, I am up to about 300 galaxies now that I have logged notes and drawings on. So tonight I want to share my observations on just a few favorite galaxies. I hope to give you some ideas for your own observing programs or sessions and encourage you to see more than I have. Especially those of you who have larger telescopes or do imaging. Also, I want to share a little bit with you about what I learned about what Herschel called the construction of the heavens. And that gives us some important context to where these galaxies are and how they relate to us. So if we're going to start somewhere with this, it's good to start with these sky atlases. This was traditionally the source of where we would find things and what to look for amateur astronomy. Herschel was one of the pioneers to actually explore beyond the solar system, and many of his discoveries appear on these modern sky charts. There are some 700 galaxies between these two atlases here, the Pocket Sky Atlas and the Tyrian Atlas. I own both of them, and I have really worn them down and dog-eared them through many years of use. The galaxies that they selected for these sky charts were they picked those which they felt would be bright enough to be accessible to amateurs, so that would be no dimmer than around 11.5 magnitude. And so for all the galaxies that I've logged so far, you can see that I'm not even at half of the total that you can find between those two. So what these atlases kind of represent, in a way, is the observable universe, not the observable universe of the Hubble or James Webb telescope, but kind of an observable universe for the amateur, for people like us. So it is sort of the hobbyist's universe that is reflected in us. So with that now, let's see if we can move on to the next slide. So here is a sky chart that shows a section of the sky. We can see the Milky Way below. And then what I've circled over here is an area that's known as the realm of the galaxies. So it starts between the bowls of the Big and Little Dipper, It goes through the springtime constellations, including Leo and Coma Berenices. It really bulges at Virgo, and then ends at the constellations of Centaurus and Hydra. And then we can see over here is a second smaller cloud that begins at Fornax and goes up through Cetus. So this particular area is known as the realm of the galaxies. It was so noted by Les Coleman. He was a former director of the Drew Observatory in Rhode Island. And Les said, nowhere else in the sky is the concentration of galaxies even remotely as high as it is right here. And he is correct. By my own estimations, there are about 75% of all the bright galaxies are just in this section over here. Another 15% are going to be in this smaller area here. So that leaves just 10% of the bright galaxies that are going to be in between those two or scattered throughout the rest of the sky. So though it may only be 10%, that's still a respectable number. That's like 70 or so bright galaxies. So if we go to the next slide. So we might ask, well, why does it work that way? So here we have kind of a modern map of the local universe, emphasis on local. And it shows that there are dense regions of the universe that are dense with galaxies. So those are superclusters. And we can see that we are here. So we are by the Virgo supercluster. But importantly, we are not inside the main dense cloud, but we are to the side of it. And then between it and the smaller cloud, the Fornax cloud. And then around the Virgo supercluster are three other superclusters that we'll touch upon a bit later. The Perseus-Pegasus supercluster, the Coma supercluster, and the Halo-Indus supercluster. And so now when we kind of have this understanding of how the universe is structured on a larger scale, the concentration of galaxies begins to make sense. So Les Coleman's realm of the galaxies is really the Virgo supercluster. So because we're so close to it. Yes?
How large is that box? I can't read it.
So this is going to be an area just in here that will cover some 500 million light years.
Thanks.
Mm-hmm. So here is something that I created myself, and this is kind of the charts of the Herschel 400 galaxies and the Messier galaxy. So what I did was I used the NED, which is the NASA Extragalactic Database. So I looked up the coordinates on the supergalactic plane for all the galaxies and their distance from the Milky Way. And then I would just kind of plot them out and make dots. And then I noticed soon that the galaxies would tend to cluster. And so I drew circles around the clusters. And then I wound up with this. And so this is a highly filtered view of the galaxies because we're just including galaxies that are in the Herschel 400 group and the Messier group. But we see that the Astronomical League did a very good job in selecting a true representative sample of galaxies because we can recognize in this the Virgo cloud over here and the Fornax cloud over here. And we can see we are there in between these two clouds. And there are with us a few other groups that are scattered in between. So this is not the Milky Way per se, but the local group that includes the Milky Way. So on the scale, a lot of things come in this little point here. So tonight I wanted to just give you this to give a little context to the galaxies we're looking at. We're going to look at this group up over here, group 19. It's right at the top of the cloud. And we're going to see, focus on that a little bit and see how knowing this context helps us appreciate more what we're looking at when we look at galaxies over here. We're going to look at one other drawing that I made, which is in the eyepiece in one field of view, where you can happen to see two groups overlapping. So that would be this group, number 11, known as the Keynes group, and group number 18, the Draco group. And so this group of galaxies are at the front of the cloud, and this one is right at the back of the cloud. And then if you got just the right part, you can see line of sight galaxies in both groups right at the same time. I'll just point out there's one galaxy way up here in the Herschel group that's really outside of here, and this is more related to the Perseus-Pegasus cluster. So it was the only one in the Herschel 400 group that was kind of that far away. We'll kind of take a quick look at that later as well. But this I found very helpful for me to begin to understand just how these galaxies relate to us that I'm looking at. Yeah.
Yeah, this is just northern hemisphere, right?
This would be, it's arranged in this way where this is by constellations in a sense. So these would be the northernmost constellations here. These would be southern constellations where the galaxies would be located. It's working though through supergalactic coordinates. So there is like a 360 degrees around the Milky Way, and then NASA assigned the certain coordinates on that basis. But it sort of tracks this way. So here you would be looking at northern constellations, and you move your way down here to southern constellations. So for this one over here is Fornax, and that's actually below our northern horizon, so it's very hard to see those galaxies. This would be Cetus over here. So we can get a better view of Cetus. It's not quite exactly in a coordinate system like north and south, but it sort of tracks it that way. So Perseus and Pegasus constellations would be here in that direction. So here I took group 19 and I made just a chart of the galaxies that belong to that family. So what all these galaxies have in common is that they are a similar direction from us and a similar distance. So they're towards the top and back of the cloud of the Virgo cluster. So you see that there are three galaxies over here that are just above the bowl of Big Dipper, three that are inside the bowl. We'll take a look at those two. There is one galaxy over here that's nearest to Polaris, and then there's one other we'll look at, NGC 3147, that is in the group that's between the two bolts. So this is not like an official group because we're just talking about Herschel 400 galaxies. So in my creation, so I nicknamed this one Cratere, meaning a group that is located between the bowls of the Big and Little Dipper. So here are drawings I made then through the telescope of these galaxies. So we start over here. This is a low power view, and this is the group that was right above the bulk of the Dipper. So this is how you see galaxies at first. You've got a context, you've got stars, you've got field stars. And here you have a nice asterism. It reminds me a bit of the back end of the constellation Cygnus, the Swan. So you look in your eyepiece, you have this beautiful asterism, you have these other nice glittering stars, and then among them are these little puffballs, which are the galaxies. So one of the reasons I really enjoyed this is because, I mean, that's beautiful. It really is beautiful to see those stars and to see the little puffballs in that eyepiece. So that's just part of the experience. So you can enjoy the galaxies even just with small telescopes and in simple ways. Like the Big Dipper is not hard to find, so it's, you know, to start off with it's fairly easy to get to these. Then, because I'm making drawings and I'm paying more attention to the galaxies themselves, so you pay attention to their shapes. You see that they have a few different shapes and they have different contrasts as well. So this galaxy here is brighter than its two neighbors. And then that tells you something now that we know the context here. It's not brighter because it's closer. They're all sitting similar distance. So there must be something intrinsic to the galaxy itself that makes that one brighter or this one a little fainter. There can be any number of reasons why galaxies will have different contrasts, but they really do. They vary quite a bit. It can be the type of galaxy. It could be an elliptical or a spiral. It can be seen at a different angle that will make it brighter or dimmer. Or it could be that some just have greater concentration of stars. But you notice, which makes it then even more nice, that they're not all the same. They really vary. So here we look at the next group that was inside the bowl. So if you imagine this is all something we're doing one evening, it's like that's my observing program for the night. So I start right on top of the bowl, now I move into the middle of the bowl. So now I see another group of galaxies. They're a little different again in their shape. These are ellipticals. You can again notice some are a little stronger than others. Another beautiful star here. Then here was the galaxy that was nearest Polaris. It was the more challenging galaxy to pull out. So definitely lighter in contrast, but you look at it and you can see it and you can get its shape. And then here was that one galaxy between the two poles in GC 3147, and this one really stood out. So then I would ask myself, well, why is it that this galaxy is just so much brighter than all the others? And we know some of them vary a little bit, but this is very dramatic. So I really loved that galaxy when I first saw it in the eyepiece, maybe some 10 years ago, when I was in the middle of doing the program. And I like it so much, I just, keep returning to it from time to time. I just viewed it again last year from the dark side in Kansas. So it turns out that that galaxy is a safe-Earth galaxy. So that means a galaxy that has an extremely active nucleus and a lot of activity that really ups the brightness many-fold over what the galaxy normally would be. So when you do something like this, where you look at a slew of galaxies at the same evening, then that allows you to notice like the really bright one. Whereas if you just did it like with just one galaxy at night, that's something that you might not notice. Well, it's a nice galaxy, but when you can compare it to some neighbors, then the fact that there's something special about it really stands out. So I thought that was kind of a cool way to look at them.
You said that's low power. How low power?
So this would be, I have two refractors. I use the 6-inch, and the one I've used for the last 10 years now is a 4.7-inch refractor. So I could use like 20 power with that. I would have a field of view that would be about nearly 2 degrees wide. So this one is a little bigger just because I use a little more magnification here, maybe 75 power on that one. But I did, because I had the stars, I was able to measure how how big the galaxies appeared, they would average about 3 minutes across, and all of them. When you look up the data, they're supposed to be about 4 minutes across, so it tells me that I'm not able to see the full extent of the galaxies. I would find that would often be the case. You're still seeing just the brightest portions of it, but they were all a similar size too.
So what's the focal length on that?
So mine is a f6. Yeah. So it's true, if you have a larger telescope, then you wouldn't be able to see some of these all in the same field of view. You might have to scoot a little bit.
How many, you said it was a 6, but what was the?
I had f6, so it's 120 millimeter f6.
Okay.
So here now is the second kind of group of galaxies that I pointed out before. What we first see is M101. So that's a very bright galaxy and very popular galaxy to see. So many people, when we go observing, usually just look at that one. We can understand why. Even with my small scope, I could pull out some detail in nucleus and bits of spiral arms. I recorded about 30 field stars that are around it. But there are other galaxies nearby too, which we really shouldn't overlook. So these two right above it to the north, those are the galaxies of the Draco group. So they are about 5 times further than M101 at the back of the cloud. So that would indicate that they're going to be similar in size to M101, but just smaller as they're further away. This galaxy is in the same group as M101, however, so then it tells us that it must really be a dwarf galaxy, really much smaller than M101. So knowing the context again for a small telescope user helps you appreciate what you're looking at. And now if you have larger telescopes or you do imaging, now you can take this another notch further. I saw a year ago someone had posted a beautiful image that they had done with M101, quadrupled the arms that I had, rich detail. But you can think of maybe doing something different next time with the image. But how about look at these up here? If they are similar size to M101, they might show a lot of detail in imaging too, or in a large telescope. I'm not sure, but it might be something fun to check out. This galaxy, I do know what it looks like because I've seen photos of it, and it's fascinating. It is interacting with M101. And when you look at the photos, its nucleus is offset, as if M101 is trying to suck the nucleus in towards a larger galaxy. And we have some material kind of trailing behind the nucleus. So that's fascinating. So that would be another idea for someone if you have access to imaging or larger scopes to check that one out and see what it looks like. So here we're now moving to, we're still around the Big Dipper, but we're at the kind of western end. This is a galaxy M108, and in the same field of view, you got another Messier object, M97. It's a planetary nebula. So here you got two nebulas in the same field of view in this small telescope. So as the small telescope user, then knowing context again helps you appreciate it. So here we have two objects that are similar size and brightness, though different shapes. This nebula represents the condensed light of millions of stars, but this nebula is created from just a single star puffing out a shell of gas. And so it's just the enormous distance that this one has receded from us from that's allowing these two to yet appear about the same brightness. So that's kind of a cool thing, when you're seeing it with a small scope. Now, though, if you approach it with a large telescope for imaging, you can appreciate this in a different way, by no longer seeing them just as smudges, but really as objects with detail. Normally, I just don't do that, but on a one-off, occasionally I'll be able to use a bigger scope. In this case, I went once to Arizona and got to look through a 20-inch reflector. So this was my view of M108 through a 20-inch reflector. And it was fascinating to me because it's not what I expected to see. You have a gouge over here. It's not even. You have different kind of bright patches, but they're in odd places. A few field stars in front of it. So we're seeing the galaxy a bit more edge on, and this is a dust cloud that's certainly in the middle of the galaxy that's creating this very unusual appearance. But it's a good reason why you want to go and check these things out. So they're going to have their own individual appearances and character, and that's what makes them interesting. So likewise, the planetary looks interesting too, a bit unexpected. You have the central star, but lighter areas within the shell itself. It reminded 19th century astronomers of the face of an owl, so we got the nickname the Owl Nebula. So again, two different ways you can appreciate galaxies: with small telescopes, knowing the context; with larger telescopes or imaging by zooming into the object itself. So we saw M108 was somewhat edge-on to us. When you get galaxies that are extremely edge-on to us, they become compelling in the eyepiece. So we know spiral galaxies are shaped like dinner plates. They're very wide, but very thin and narrow. And so when the narrow end is presented to us, it's fascinating. So here are three of my favorites. The first one is, on top, is known as the knife edge galaxy. And when you first look at the field where it's located at, you don't see the galaxy, you just see the field stars. And then you have to look in the corner of your eye with averted vision, and then suddenly it appears. And it appears as this long sliver out of the corner of your eye. And it is a wow moment when that happens in your viewing. And a lot of amateurs that view them feel the same way. Tom Palakis is an amateur astronomer who liked these so much he put together a list of about 50 of these for people to seek out and view. So the next one here is NGC 891. This is not in the Virgo cloud, but is right between us and the Virgo cloud, about halfway. And it's a galaxy that is almost identical to the Milky Way. And so it shows us then, if we were there looking at the Milky Way, this is how the Milky Way would appear to us. And so the Milky Way would be kind of a challenge object from that distance. And it's a similar effect where first you just see the field stars, and then it'll appear at the corner of your eye. So this was something I first saw at CF maybe more than 10 years ago. It's a galaxy that I returned to from other dark sites. And then this one down here is known as the Cauldron. And this galaxy was imaged by the Hubble Space Telescope, and then the Hubble scientists noticed that it has a very active nucleus that reminded them of a cauldron with all kinds of things bubbling out from it. So I can't see things like the Hubble, so I used my imagination a little. I imagined that these three field stars were a cauldron, and that the galaxy then, seeing it out of the corner of your eye, is like something that's bubbled up and misted up from the top. So this is a way you can appreciate them just with small telescopes or visually. Very cool effects, especially since they disappear when you look at it in direct vision. But if you image, then you can appreciate them in a different way. So someone might want to try and look at this galaxy, see if you can get any of the active nucleus. It might be possible to 891 is a beautiful dust lane that you can image and pick up. And the knife edge is fascinating because there are filaments encircling, swirling all around the galaxy that you can't see visually. And astronomers are speculating that the knife edge galaxy must have interacted with another galaxy in the past to cause and create all these interesting filaments around it. So again, two different ways you can appreciate them. So here is a group of galaxies that I call dramatic galaxies because they're really fun to look at. These are all going to be in the Virgo cloud. So this one here is in the constellation Sextans, and this is one I saw when I went to a dark site in Kansas, and I was able to get 13th magnitude stars, and that is in my 120 millimeter refractor, my 4.7 inch refractor. And so you're doing pretty good if you can get that thin with such a small scope. At first, you just see the field stars, and there are two over here of 12th and 13th magnitude. And then, as you look, suddenly the galaxy appears, and it seems to flare out from the field stars, reminding me of the field stars being a wick in the galaxy, like the flame of a candle burning from the wick. So just again, a very beautiful and nice wow moment when that appears. The next over here is something that I thought was one object at first when I looked at it. It reminded me of a planetary nebulae because those are often odd shapes. But it turns out they really are two objects when you look at it closer. And they turn out to be colliding galaxies. So here we have the spiral galaxy colliding with an elliptical galaxy. Over here we have a very popular galaxy, M51, the Whirlpool galaxy. And this one is clearly interacting with NGC 5195. You can see even in the small telescope how material is being drawn from one galaxy into the other. M51 itself shows really good detail in the small telescope where we have great conditions. I see some 13th magnitude stars sprinkled across the face, and then another wow moment when you can start to have the brightest parts of the spiral arms materialize in the eyepiece. So I viewed this one many times. Drew gave a talk a couple months ago where he was saying that the 18th and 19th century astronomers, when they made their drawings, the drawings wouldn't always agree with one another. And this galaxy, when I viewed it another time, I saw not this, but a ring, a real ring all around the outside of the galaxy. And that was how William Herschel had seen it also. And that is just the trick of seeing conditions, resolution, how your eye is interpreting faint and difficult detail. So it's fun to go back to some of these galaxies because you can always see more detail or see them in a different way. So in this case, it's not really a ring as Herschel thought, but here I have a little better resolution so I can see the spiral arms. I can't quite resolve it with a small telescope to the full extent of the arms, but you can certainly do that in 12 inches of aperture or greater. So over here we have just a pair of neighboring galaxies that are close to each other. When I did the Herschel 400 program, I had been able to see the two galaxies, but I only could see like the brightest parts. It looked interesting to me. I wanted to return to it again one day, and I was finally able to last year at Cross Timbers in Kansas. And there I finally got to see the full extent of the galaxies. And then it had a really cool effect, like a pair of eyes staring right back at me. So those are kind of fun to seek out and look at. Here is something that I made an observation on many years ago in CF. I mean, it took me about 14 years to do the Herschel 400 program. And this is the cocoon galaxy, it's called. So the bright galaxy is easy. I even saw it from my backyard when I lived in Lombard. But it has a very faint companion. And so that takes some work and dark skies to pull out. So I was able, with some effort, finally to detect it. At first it seemed like it was attached, but it really isn't. It's just right next to the much brighter galaxy. But when that materializes, it got a really cool effect. And then here, lastly, we have M85. It's a bright elliptical galaxy in the Virgo cloud. And it has a nice field star to the south of it. What's cool with this is there's a companion galaxy, and it looks a lot like M85 and even has a southerly field star too. So the effect of the eyepiece is as if you have a ghostly mirror image of M85. And so another really cool visual effect worth seeking out. So here, we're moving now to the heart, towards the center of the Virgo cloud. This is in Coma Berenices, the Coma group. So as you start getting to the center of the cloud, then it's easy to see like lots of galaxies at the same time. This is also something I made of observation at CF. We see a nice group of 4 galaxies here, with the 5th one just to the south. And my wide field refractor, I can get them all in the same field of view. If you have larger scopes, you have to slew a bit, well, these should fit nicely. And it's a beautiful view as well. We can see their different contrasts, their different sizes and shapes, and nice field stars. So just to see all these little puffballs all at once is, again, a beautiful thing to look at. So one thing that's interesting here, the center galaxy is known as the Saturn galaxy. So we just talked about M51 before, how it had kind of a false ring that was really more a trick of resolution than a real one. Well, it turns out this galaxy has a real ring. So its spiral arms really are a true ring around the galaxy. So hence it got that name. So I can't tell that with my small telescope, but if you image or have a larger telescope, then you might be able to pull that out. I think almost certainly with imaging. So that would be another interesting target maybe to look at. So here now we go to the very heart of the Virgo cluster, what amateurs have also come to call it downtown Virgo. So not my nickname, but it is one that's kind of caught on and very apropos. So this was a view that I made with a small refractor from CF, and this must have been about 12 years ago. And sadly, I cannot do this anymore today. The light pollution has really gotten bad here. So this is just relegated to what we used to be able to do, which is really sad. I was able to see this part of the sky again because it's so compelling a year ago, but I had to go more than 700 miles from here to Kansas. And even there, I noticed, it's not as clear as it used to be. But anyway, back then, you could really, with a small telescope, see all this rich group of galaxies. This is the richest field for galaxies in the entire sky for small telescopes. So this over here begins with M84, and then it's followed by another elliptical Messier galaxy, M86, and then just flows up like this. These groups are known as Marcaron's chain, after an astronomer who was able to establish these are all gravitationally bound. And then you can follow your eye just up to additional galaxies, sort of another chain, all the way up to M88. So this covers a 2-degree section of sky. There's a dozen galaxies that you can see just with a small telescope. If you have a larger telescope or imaging, then you can see even more. So it's just an incredible part of the sky, just incredibly beautiful to look at without question. And so I guess all is not lost for us here in Illinois. It was just a week ago that we had proposed from James, who did imaging from Oak Brook, not Oak Brook, from Oak Park, where he lives. And it was the Markarian chain. And so with imaging, I guess you can still say today that you still see things like this from our skies. So now that's kind of the Virgo cloud, a few highlights. I've hardly touched on all of them. I mean, just to get to what we just saw, Markarian's chain, there's a lot of galaxies you can work through to get there. The Virgo cluster, that's not the Virgo supercluster, just the Virgo cluster, but the supercluster got its name from. That is huge in itself, and you can spend incredible numbers of nights just exploring that part of the sky. But once this is done, and the kind of springtime constellations go away, now we are still able to see some isolated galaxies from time to time. So a favorite isolated galaxy of mine is right next to the globular cluster M13. So this is an easy catch because everyone's familiar with M13. So you just got your scope on that, and then if you look kind of to the north east, then you can pick up the galaxy. So one other thing I wanted to point out is because I do sketching, I am now able to recognize M13 in photos. Just if you show a photo with no caption, and I look at it, I can recognize that's M13. And I can do it because there are particular stars that are on the periphery that you can pick up on. And I wanted to point them out to you so that you'd be able to recognize this going forward. So if you look at it through a larger telescope or image it, you will see a diamond asterism of stars at the northern end of M13. So this is like the densest part of the cluster. Above the densest part, this diamond asterism of stars appears. On the southern end, there's a stream of stars that are punctuated by a brighter star at the end, sort of like a staff. Then on the eastern side, we have a kind of crown-shaped group of stars. And then on the western side, we have a triple star. And there's a couple streams of stars that kind of frame it nicely, and then even a double star outside of that. So next time you look at M13, you look for the diamond, you look for the triple star. That's a way to single it out from all the other globulars. And then, of course, don't forget to look for the galaxy. So here we have some more isolated galaxies. This one is known as the fireworks galaxy. And that's got that name because it happens to have a lot of supernovae go off on it from time to time, more than what's typical for a galaxy. No one knows why, but that's how it got its name. And when I looked at it, it's right next to a very bright cluster, an open cluster of stars. And so between those two, that's a really nice view in the eyepiece. So this is all in a low power field of view. You get both the galaxy and the star cluster. So this was a drawing I made when I lived in Lombard from my backyard. So Jim Hopkins gave a talk last month about the Nebraska Star Party. So I thought I'd put this drawing in. So this is a drawing I made of the same galaxy when I was at the Nebraska Star Party. So here we have the same object, the same observer, and the same telescope, but it's very different. So you get to better skies and you can really see more detail. And here, just a small telescope, I'm beginning to get some of the spiral arms of the galaxy, which is really cool. So it's good to look at these things more than once, especially if you get to different skies. You can always see something more than you did before. And then the last isolated galaxy that's kind of cool is this one. It's known as Mirax Ghost. So you have a very bright second magnitude star in the constellation Andromeda called Mirax. So it's easy to find. You just got your scope on it. And then when you look at it right there in the same field of view, the galaxy will appear. But the light of the star is so bright that it really makes it hard to pick out the galaxy. So hence it got the name the Ghost. But it does appear, and it is really beautiful, especially next to this very bright star. You can even see kind of a bright nucleus to the galaxy. So once we get into, well, Andromeda and that, the fall, then it's good to check out the galaxies of Cetus, because that is the second major cloud that we are associated with. We can't see the brightest section of Fornax itself, but we do get Cetus, and there's still an area rich with galaxies. So here I have a series of drawings that I started on the eastern side of Cetus and worked my way around clockwise, all the way around the galaxy, and then all the way back. So when we start on the eastern end, the brightest galaxy in Cetus is the Messier galaxy, M77. So it is also a safer galaxy, so very bright and very compelling to look at. So most people will just look at the Messier galaxy. But in the same low-power field of view, there is an edge-on galaxy as well, NGC 1055. And that one is kind of the opposite end of visibility. That's an edge-on, you need to look at it to the corner of your eye kind of thing. But when you have the really bright one and edge-on together, it's a compelling combination. So definitely worth checking out. So a good place to start when you go from there. The next galaxy we have is NGC 936. And this one, the field stars make it interesting. It reminded me sort of a fisherman dropping a line. And you kind of have a hook shape to the field stars, and it looks like he's snagging the galaxy. Then we move further along Cetus, and now we can see, because it is a rich area of galaxies, 3 in the same field of view. So then that becomes really nice, especially with the beautiful field stars sprinkled in between. And then we keep moving to the western edge of the constellation, and we get NGC 157. And what I liked about this one is that the field stars sort of reminded me of a wave that had kind of washed the galaxy up the shore. One way to look at it. Then now we start working our way back around the constellation. We have NGC 613. And this one is a nice spindle with a bright nucleus and 3 interesting field stars right above it that sort of remind me of like a wing. Sort of a wing of the galaxy. And then lastly, as we're coming back around towards where we started, we have NGC 1084, another beautiful spindle galaxy with a nice field of stars. So you can spend many evenings actually in Cetus. This is just a sample of the galaxies you can see because it's a very rich area. So now that we've seen the smaller cloud a bit, and the larger cloud. So this is the group, the M81 group. And this is sort of not far from our local group. So it's like another in-betweener, if you will, between the 2 clouds. It contains the brightest galaxy pair in the sky, which is M81 and M82. Many people just look at the 2 Messier galaxies. They are beautiful to look at. But there are actually 2 other galaxies in the same field of view as well. So you should, next time you take a look at this part of the sky, you should definitely look for the other 2 galaxies. And also, it's a rich area for double stars. So there are two pairs of double stars right near MED1, so they're right over here. And those are really nice to look at. They have nice colors, and they can be split fairly easily. And it's just another beautiful thing to see, as well as the galaxies. And there's a third double star right by NGC 3077. So next time you're here, don't just check out the Messier galaxies, but look for the other companions and definitely the double stars. So now we're going to go to the local group itself. And because we're in the local group and the galaxies are out really close to us, comparatively speaking, they're really nice and large in the small telescope. So this is M33, the pinwheel galaxy. And when you get good nights, you can resolve it and resolve the spiral arms perfectly in this galaxy. And they take on this kind of S shape, and that's typical for how it will look in a small, like 4-inch refractor. As you get larger telescopes or imaging and a more rich detail emerges, this is kind of a typical small telescope view, but still cool to cleanly get the spiral arms. And then this galaxy also has a nebula, and this is NGC 604, right at the northern end. And so this is the Orion Nebula of the Pinwheel Galaxy. So it's another huge cloud from which new stars are created. New stars are shining harsh sunlight back at the cloud. It makes it fluoresce so that it responds well to an O3 filter. So it's cool to look at that nebula in the galaxy and blink it with your O3 filter. It's subtle because it's good distance away, but it's still noticeable. And so it's also showing us that here is another Milky Way that has spiral arms and even has nebulae. Then here we have our nearest neighbor that is comparable to the Milky Way, the Andromeda Galaxy. So this is a view I made from New Mexico in January of last year. And what you see here, it spans to my drawing here 2 degrees of sky. So that is 4 full moons side by side. It's actually even larger than that, but that's what I could resolve, and it's still pretty impressive. And when you get a clean, good look at it, you see the nucleus of the galaxy, but you notice that it is brightest right at the very center, and then gradually fades as you move from the very core out to the edge. And Brian Skiff, a professional astronomer, pointed out that that's how many elliptical galaxies will look when you can get a clean view of them. They're going to be brightest right at the center. It's a gradual lightening as the densities of stars begin to thin as you move from the very core to the edge. So it was very interesting for me to see that these effects that we see in elliptical galaxies also hold true for the cores of spiral galaxies. So around the core, we have the spiral arms, and then this has a nebula too, NGC 206. So this one does not respond to a O3 filter, so it tells us that it must be a nebula of stars, which would be like a star cluster, more like a star cloud. This equivalent would be Messier 24 in the Milky Way. But it's really cool to see again how we've got a galaxy like our own that has spiral arms, nebulae. Outside of the galaxy itself are 2 companion galaxies, Messier 32 and Messier 110. They would be the equivalent of our Magellanic clouds, but there is even a third satellite galaxy to Andromeda, which is NGC 185. Now this one is about 6 or 7 degrees away from Andromeda in the constellation Cassiopeia. but yet astronomers have established that it's a true satellite, just like these two. And I determined that it's about 2.5 galaxy diameters from Andromeda, whereas our Magellanic clouds are about 1.5 galaxy diameters away. But still a true satellite galaxy. And now when we compare that one with M32, you can see they're both dwarf elliptical galaxies. They're both similar distance to us, but yet appear very different. And so here, M32 is very condensed and bright, and this one is very loose in structure and much fainter, harder to see. So when I did the astronomical lead program for globular clusters, you were supposed to note the concentration level of the globular. So was it dense and bright, or was it loosely structured and fainter? And so for me, this was interesting to see that elliptical galaxies will have similar characteristics to globular clusters, and that they can be dense or loosely structured. There is even a fourth companion galaxy that is near this one, 185, but I just couldn't pull it in, but something I'll keep working at to see. And there is also a globular cluster, which is the equivalent of M13, called G1, that I'm also trying to work at and pull out its 13th magnitude, but within reach of a small scope. So a lot of rich detail to see in this galaxy. So here we're going to wind up now towards away from the local group again, and this is a favorite galaxy of mine, and is another object that's kind of in between the clouds. It's in the constellation Pegasus. It's NGC 7331. And this galaxy I observed from cross timbers in Kansas with my 120 millimeter scope. I was again able to get to 13th magnitude stars. So this one here is a 13th magnitude star. And this galaxy 7331 is a near twin of the Andromeda galaxy, but it's 20 times farther away, but the same size and even the same perspective to us as Andromeda. So again, you can see the bright core, you can see how it gradually fades a bit as we move away from the center, and then you can see the spiral arms and even a sharp edge, which indicates the presence of a dust ring. So this is all wonderful detail for a small telescope, so when you get the right conditions, it's wonderful. And then I saw a galaxy appear next to 7331, and that is something not on the sky charts. It's 13th magnitude, not on the traditional sky charts, that is. And it's NGC 7335. At first you think it is a companion to 7331, but it's not. Line of sight is all we have. That galaxy is 6 times further than 7331. So it is a true member of the Pisces Perseus cluster. And so that was really cool to see as well. There's a couple other galaxies that are companions to the faint one, and collectively they're known as the Fleas. And Sue French, who is a frequent contributor to Sky and Telescope magazine, was able to see all of the Fleas with a 4-inch refractor. So, it can be done. And that was just a moment here where I'm kind of getting all that my small telescope can give me. When you get those moments, they're wonderful moments. So above this is 1961, NGC 1961. That was one I showed you at the beginning of my chart. That was kind of way at the top, removed from all the other Herschel galaxies. So that is also a galaxy that is associated with the Perseus-Pegasus supercluster. And this one is about twice the size of the Milky Way. But because it's so far away, I was only able to see the brightest section of it. And that took some work to do as well. but it is really nice once you can catch it. So here I have kind of a bit of a summary of what we've seen tonight, and that is here is the Virgo cluster and the Fornax cluster. Here we are in between the two, and so most everything we looked at tonight is just right in here, and that would make sense in a way because the brightest galaxies are going to be the ones closest to us. So this is a bit of a cartoonish representation of the superclusters that are around us, but it still, even if imperfect, a model can give us a lot of useful insights to nature. And here we see this is where 7331 is that we just looked at. They're in the line of sight at 7335. And then here is where 1961 would be. So when you have this kind of perspective, what it's done for other amateurs is to create new ideas for things to observe. So a lot of people now like to go and look for the galaxies in the neighboring superclusters, especially their equivalent of downtown Virgo. So that would be Perseus, a section called Perseus A for Perseus Pegasus, the Coma cluster for here, and then there's also a group of bright galaxies for the Indus that would have to go to the southern hemisphere and however to access that. And so it's fun to look at like a Cloudy Nights blog, and people will have like, here are my drawings of the galaxies in these superclusters. So that might be another idea, especially for those of you with larger telescopes or imaging, is that now that we've seen this, we can try for some of the brighter numbers over here. So this does represent kind of the limit of what my small telescope can access. But it's still a very impressive part of the universe. So the last thing I kind of want to point out is that for almost all of humanity's history, this dot is enclosed the universe as we have understood it. So at the time of about 2,000 years ago, the idea was you had the Earth as the universe with the celestial sphere around it. That was the Ptolemaic universe. And it was estimated that that universe was about 50 million miles in scale. So for us today, that doesn't sound very impressive. That's just a little more than halfway to the sun. But they had a different concept then. So the universe was very small comparatively back then, and it was that way for humanity for most of the time. It was just as we get to maybe the 17th century or so that the concepts begin to take hold that maybe the Milky Way is the universe. And that still would be within this dot over here. And that was it. And it wasn't until 1925 when Hubble published his first papers that we knew that there were other island universes beyond the Milky Way. And that's not really a long time ago. I mean, that was 6 years before my dad was born. And so my dad and his generation were one of the first to grow up with knowledge that the universe is actually beyond this point. And my dad is still alive and well. I just visited him with my mom on Sunday. So within kind of a human lifetime, we have gone from this dot to such an expansive universe. And this is just a little corner of it. So that's an amazing change in scale. So it is both magnificent in its scale and a little bit frightening too. So I'm going to finish tonight with this. So this was my attempt at downtown Perseus Pegasus. And you can see it's kind of pathetic. But it's hard, to see galaxies that far away. So this was something from New Mexico a year ago. but I was able to see at least 3 of the brightest ones, and it's known as Perseus A. And so what was great for me is then not just the smudges that are there, but understanding what they represent. So when the light first left these galaxies, we had the Triassic period here on Earth. It was 250 million years ago. So from Ptolemy onwards, humans always thought that everything was eternal. The heavens were eternal, the mountains were eternal, the oceans were eternal. And now we learn that's really not true. Back in the Triassic, you didn't have the continents, you just had one continent, Pangaea. And where we're standing right now is a lot closer to the equator. The Great Lakes didn't exist, the Atlantic Ocean didn't exist, the Himalaya Mountains didn't exist. You had dinosaurs here, and the dinosaurs were looking up at the sky. And the sky that they were looking at is nothing like the sky we have here. Even the constellations we see today did not exist. You take a look at Orion, for example, and the 4 bright stars, Betelgeuse, Bellatrix, Rigel, Saiph, and the 3 stars that make the belt of Orion, all those are giant young stars, 100 million years or less in age. They simply weren't around back then. And those that are stars similar to our own have different orbits around the Milky Way. They were scattered in different places of the sky altogether. So it's the sky that the dinosaurs were seeing is completely different from the sky that we have today. So even the heavens, as we know them, are not really eternal, but constantly evolving. And so that was where we were when this light first left. And now finally it takes all this time to get to us, all the amazing changes that have taken place. So when you put it into that kind of perspective, even though this is kind of the hobbyist universe, it's still a very impressive part of the universe, I think. So that's kind of what I had to say for tonight. Yeah?
So Ron, when you're doing these drawings, I'm
Mhm.
assuming you have a tracking scope. But
So-
how long does each one of these drawings take? And then you mentioned filters, O3 filter, but what other filters would you use?
So when you're observing galaxies, filters don't help you.
Yeah.
So that's a bad thing because nothing is fluorescent. So then I have to just go with what I can get. That's why light pollution is so devastating, right? And then I will have a clock drive. Sometimes when I'm out in the field, like when I take my small scope, I can put it in a suitcase and fly. And then I'm not able to bring my tracking mount there. So I just have to, I have a different mount that I can fly with and set up. And then it's nice, knobs that you can move it to track. You're not, with my scope then being such a wide field, then I don't have to worry quite as much about tracking as you would with a larger scope. And then I will have a notebook and a red light and be observing and then making my sketches and taking notes also. And then that helps me. And then all the sketches you see here are refined sketches, but I have all the original material in notebooks. So I have like a half dozen notebooks now filled with sketches over the years. Yeah.
Do you do imaging as well?
I don't.
So that's what's so interesting to me. I mean, I expected to see images tonight,
Mhm.
and those are just daunting if you're new to astronomy and you don't have the best equipment and you're not interested in spending hours with Photoshop.
Mhm.
So I've only seen a few galaxies, and I'm just like disappointed because
Mhm.
the images are what you want to see, but you've kind of opened up a new way of looking at this, where you can just
Yeah.
appreciate what you can actually see.
Right, and that's what part of what my talk was about tonight is that you can appreciate this in many different ways.
Yeah.
Right? So for me, I've always enjoyed just seeing them with my own eyes.
Yeah.
And then it is like pay attention to the details or know the context, and then it becomes much more interesting.
That's interesting.
But then also, like, there's a lot for imagers too, right? I hopefully gave some ideas to people of new things you might want to image and look at too. So many ways we can enjoy it.
It's a little bit like birding, isn't it, Ron? It challenges your observing skills, and then
Yes.
some of the birders do little drawings too.
Oh, exactly. Yeah, that's a good analogy. And then sometimes they are very challenging to me. So for some of the galaxies I had, like they were so faint that I couldn't hope to see them from Illinois. But I would go out and sketch the field where they were located, so I'd become familiar with it. And I vividly remember one pair, NGC 3900 and 3910. And they were among the most challenging in the Herschel 400, just a couple more. They were a real bear to try and catch in a 10-inch, and I'm trying to do it with a 120 millimeter. So I get out to cross timbers, and then I have the field. Now I'm familiar with the field because I did my homework. And then they appear, that wow moment. And I never forget the feeling, because here's something I've always been denied. You can't see it, it's too faint, and now finally you catch it. And it's just a simple spindle, a couple of spindles, but boy, is that satisfying when that happens. And of course, then that that little victory kind of pushes you on to keep going with the program. Yeah.
So again, when you're framing your field,
Mm-hmm.
do you use any software to help you to figure that out? Because you know what your aperture is that you're going to use, right?
Mm-hmm. So I did use software, not as in that sophisticated sense, but it would be to get more detailed maps. So if you would have the pocket star atlas is great to get me in the area, but now I have to see exactly what my eyepiece is seeing, and then I better have a better charts. So that's where technology came in. So I wasn't completely 19th century.
Well, I was going to say, do you
Mhm.
create templates for your charts that you do have?
So
that
I
you
would,
know,
I did
like-
have charts.
Oh,
But I would still use them like in a star hopping way. It's
Yeah.
like, okay, can you identify these stars in your telescope, and then you know where to move, right? And kind of where to concentrate your gaze. Yeah.
And would you always decide, like, this is the star that will be kind of like the central point or something like that, one particular star?
So you would have to get stars that would allow you to hop. That would be the thing. So I start with the brightest ones that are in the pocket sky atlas, so I match pocket sky atlas to what I see in the eyepiece, and then I hop, and then I see the stars in the eyepiece. Now, are you matching them with your chart? If you're not in the right place, and then go till they match, and then you know where to concentrate your day. So invaluable with these very faint things to pull them out. Yeah. So, okay, well, thank you. Thanks for...